Okay, I'd like to show you the spectrometer program now. So the spectrometer program is called Ocean View. You may have used it in an earlier lab in modern physics on a different computer. Any event, here it is. The program is running now, and it's what it's doing is it's taking a spectrum and displaying it. Actually, I've started this way. I want to show you something interesting about our laser. Right now, I've just turned the pump laser on. The Ti-Sapphire laser is operating, but it's operating in what's called continuous wave mode, which means that it's not producing pulses. It's just producing a regular laser beam, continuous laser beam. You'll notice the spectrum of the laser beam here is very narrow, kind of what we expect for a laser, which we normally think of as a monochromatic source. In a moment, I'm going to mode lock it, and you'll see the spectrum change. Okay, here we are, 1 second. There, it's mode lock now. Notice how different the experiment looks? Here, I'm going to change the integration time so that we can see it more clearly. Now the spectrum is very broad. It's about 40 nanometers wide. It's not really monochromatic at all anymore. And this makes sense. In order to produce short pulses, we need to have a wide bandwidth, a wide frequency bandwidth. This is really expressed in the uncertainty principle. If delta T is very short, then delta E has to be very large. And so the width of the spectrum, or the energy of the photons, has to extend over a wide range. Okay, well, now we're looking at the laser spectrum, and we can do a couple of things I want to show you. First, while this is operating, you can change the integration time. Right now it's at 36 milliseconds. I can set it with automatic, which will try to find the best, or I can type in a number myself or adjust it with these arrows. So if I put in 10 milliseconds now, oops, that was 101. Well, you can see what happens, we overload. If I put in 10, there we are, very short. Okay, let's go back to about 37. The second thing I can do is signal average. If I change this number to 10, then it will show us the continuous running average of the last 10 spectra. It's very useful. The next is called boxcar width. This allows boxcar averaging, which is a kind of smoothing. So if I change this, say, to 4, then it will smooth over a window of about 4 pixels. And that's kind of useful so that we don't get caught up in the tiny details. Okay, so I'm going to suggest you use a boxcar width of around 4. The other controls we don't need to look at. Very good. Suppose we want to save the data. To save the data, we do the following. First, we have to configure the save. So that's this icon here. If we press this, it will give us some information. We can say, okay, well, with the format of the saved data, ASCII, which means just text, and then target directory. Here, let's check this. So right now it's going to save it to this folder. Let's open the folder, save it within the folder Advanced Lab Student Data, and then here you would add a folder with your initials, but I'll put it in my folder for the moment. So we'll choose that folder. Okay, there's the folder here. And then we give it a base name like, I don't know, could even be my initials, very boring. And then we can tell it how it's going to save the data. It could be the base name plus the date and time, that's the timestamp, or it could be a file counter, base name, and then file number. Apply, and now we'll exit, and it's all set. Now when we're ready to take a spectrum, we just click on this icon. And each time we do that, it will save a spectrum to the file. Okay, that's how this program works. If I want to pause, I can pause. And if I want to close the program, I can do that here. Okay, it takes a little moment to close. Now, if I go to my file, my folder here, I can see the two files that we've saved. Let's go ahead and open one of them, and you can see what it looks like. It has the wavelengths in the first column and the data intensity in the second column. If I open the data in another program like Kaleidograph, just give me a second. Okay. I can go and find the file. Here we are. Here we are. There it is. I'll select open. And now I can open the file. Notice there's some header information that I'd like to skip. There we go. And then now I'll open it. The delimiter is a tab. That's what this dot means. And so it's all set. Here's the data. And now I can make a graph and make a plot. And there it is. Everything looks good. Okay, so that's how the spectrometer program works and how we can save the data. Let's stop here.